Welcome to the Profile Corner. Today's video is about creating smooth ellipses using a woodworking router. An ellipse is essentially the same thing as an oval. You might use this to create an oval top for a picnic table or some sort of a dining table or a coffee table. This will build on the previous video in the series, which is about creating smooth arcs or curves in boards using a woodworking router. So today's video we'll be talking about creating an ellipse. There's multiple ways to do that. There's an easy way to do it, an even easier way, a stupid simple way to do it, and also a hard way to do it. We're going to explore each of the methods. I'll save the hard method for the last because a lot of people probably think that it's the easy method. Okay, so let's get started here. All we need is a little bit of math to make this really an easy thing to accomplish. I have here in front of me a sheet that I'll put up on your screen. Also, I've prepared this to show how to create an ellipse using a little bit of simple math. Okay, so there's a couple different methods that you can use to figure out all the different points that would be necessary. Those would be X and Y coordinates or long in the short direction measurements. There's a couple different formulas that are on the internet that I found, and I believe that I went through these in math classes, either in high school or in college, where I learned these as well. One of those formulas is here, and it looks like it's kind of hard to understand it, but Rx, in this case, is the major axis width. It's actually 1/2 of that. It would be the radius of the long dimension in the ellipse. XY is 1/2 of the minor axis, which would be 1/2 of the short width of the ellipse. And here's a formula that I found on this website here that explains how to calculate the values. Here you can put in whatever you want for the value of X, and Y then has to be calculated based on whatever's put in for X. Your value of Rx, which once again is up here, would get squared in the denominator here. The value of Ry would also get squared. And the idea here is that when this ratio becomes 1, because of the same value, then you have 1 plus something equal to 1. So when this is 1, this has to be 0 for the result to be equal to 1. Likewise, when this result is 1, that means that this result over here has to be 0 for the result to equal 1. So then that would be the two points at the long side and also at the short side of the ellipse is when this comes out to a value of 1, with this ratio being 1 or this ratio being 1. So it's kind of complicated. I worked out a formula here. This formula is the same as this one over here. I just worked it out so that whatever this is equal to, that's the value of Y. Okay, that looks like it's extremely complicated, right? I said that this was the easy method of doing it. Well, the neat thing about it is that you can create a formula in a spreadsheet that does this calculation for you. So for instance, if you have Microsoft Excel or Google Sheets or some other free spreadsheet program, you can put in a formula that looks like this into the cell that's right here, which is C7. So there's a 7 right there for the row and column C. You put that formula in there with a value in here, and it'll give you that calculation. And what I've done here is I've taken this value up here, which is x, which is, once again, the radius of the long side of the ellipse, and I've taken that value, divided it by 10, and then I just increment the value of x by that, going out 11 times, 11 cells across, until I reach the final radius here. And so with this formula right here, in the cell, once you paste it in there, then what you can do is you can copy that cell and paste it here, and here, and here, and here, and here, and here, again, and again, and again, and again. And then that'll give you the values of your x and y coordinates that mark out the curve for the ellipse. Now what I've done over here is I've created what's called an XY scatter chart in Excel that plots out these coordinates, and here you can see that it is essentially graphing out one corner or 1/4 of an ellipse. As you can see, it's nice and smooth here, and then there's a huge gap here. And what that suggests is that we probably need a couple more points out in this area here so that we can get a better idea of how much of a curvature we have between those 2 points. So what you would do then is you go back into here and you could add in a couple additional entries in this area here with x values in between those values. And then that would give you a couple additional points out there, and then you could transfer those measurements onto the board. Okay, so that's the easy way to do it. An easier way to do it is to use something called polar coordinates. Here we have x is equal to whatever rx is, this value up here, times the cosine of an angle. Y is simply ry, this value up here, times the sine of that same angle. So if we run from 90 degrees, which would be, if this were the board that we're going to create the ellipse on, and this were the center line of the board, 90 degrees would be up here, and 0 degrees would be over here. If we go from 90 degrees to 80 degrees, then 70, then 60, 50, 40, 30, 20, 10, and then 0, which would be out here, then we get these numbers that you see here. That's assuming that the 1/2 of the major axis is 23 3/4 inches, and 1/2 of the other minor axis is 11 3/4. Okay, so that gives you these values here. So here you would plug in values up here in this yellow section, and here you would plug in the angles that you want to use. Okay, Excel is a little bit funny in that it cannot use the degrees directly. Instead, what you have to do is you have to translate those degree values into what are called radians. So essentially, you take this value, divide it by 180, and multiply it by the value of pi, which is roughly 3.141592, and so on. So what you would do is you would put into C18 this formula here. You would put into C19. Once again, the value going into C18 calculates the radian value of the specified degrees. And then you go into C19, which is this cell right here, and you plug in this value here, or this formula here, into that cell, and then you plug in this formula into that cell. And once you get those in, you can copy these 3 cells, and then you can paste it across into all these other cells, and that'll give you your other values. And the nice thing about using polar coordinates is, while it gives you the same values, if you have the same x value you'd have as you have up here, you'd end up with the same y value. But the neat thing about it is that if you plot the x and y coordinates, you get a very smooth ellipse. So this is the easier method of doing it. Okay, an even easier way to do it, instead of plotting those directly on the board, so let's say that this is your board here that we want to create an ellipse on. This claims that it's a 2 foot by 4 foot piece of plywood from Home Depot. It actually measures a 1/16 of an inch less than that in each of the directions. So it's not quite 48 inches that direction. It's 47 and 15/16. And this way, it's not quite 24 inches. It's 23 and 15/16. So that's going to give us a little bit of a hassle. But if we can find the center point of this, what we can do is we can measure from that center point what's been calculated on this sheet. So instead of just having this blank, we'd actually have what I've already done here. Here I have the center indicated. Here's the line exactly halfway between the top and the bottom. And same thing here. Here's a line here. It's exactly halfway between the two, the major axis, essentially, and the minor axis. So that's our center point right there. And then we use our calculations to figure out exactly where we need it to go to. Now, I've already laid some of that out. I'm going to flip this over a little bit so that you can see it more easily, what I've done here. I've marked here each one of these. I'm using the polar coordinates, by the way. The first one says that at 0, which is the center point here, we're at 11 3/4. The next one, we're at 4 1/8. So that's the spot right here. I drew a line up to here to reach that point. At 4 1/8, we should be at 11 9/16. So it's 11 9/16 from this point here up to here. Okay, the next one should be at 11 1/16. Excuse me, should be at 8 1/8, which is over here. That one should be at 11 1/16, so that's right here. And then the next one should be at, let's see, 11 7/8. It's over here. Should be right there. And then we keep going across. Right there, right there, right there, right there, right there. And then over to there. So then if you were to take, because this closely approximates the shape of an ellipse, what you could then do is you could just then draw straight lines between each of those points to come up with the shape of your ellipse. And then of course you'd want to have them slightly bowed outward instead of having straight lines, but the straight line will give you an idea of the shape that you need. Okay, so I said that this is the easier method of doing it, right? Well, in the last video, we created templates for doing this so that we don't have to do the same measurement in all 4 quadrants of the ellipse. What we could then do is we could take a 1/4 inch sheet of MDF, which I've got here on the table. And you would only use 1/4 of this. And what you could do is you could put those same points into 1/4 of this, mark it out, and then of course draw in the slight curvature between the points. Take it over to a bandsaw and cut this out. And then you could smooth it, refine it using an oscillating spindle sander or some other type of a sander. And now you've got a template to make 1/4 of your ellipse. And you could just, and if you actually allow this to be extended out an extra inch in each of these directions, then you'll actually find that it's a lot easier to make sure that template is not going to allow the router to cut where it should not be cut. So once you've got your template laid out, then what you can do is you can use double-sided tape and attach this template that you create to the board that's going to have the ellipse cut into it. And once you would use potentially a bandsaw or a jigsaw or something like that to cut maybe 1/8 of an inch away from the line of where your pattern's at. And then what you can do is you can use a flush trim bit or probably a pattern bit, which would have, of course, the bearing on the top. And you could use that bit to flush trim back to the shape of the ellipse that's in this 1/4 inch MDF. Then once you get one corner or 1/4 of the ellipse cut, you just move your template over to another 1/4 of the ellipse and you repeat the process, and then you've got four quadrants here that have the full ellipse in it. Okay, so that's the easier method, using an MDF template that you create using the math formulas. Now, it sounds kind of challenging with these math formulas, but it's really very, very simple if you have access to a spreadsheet like Microsoft Excel. It doesn't take much to type in these formulas if you know what the formulas have to be. It's a very simple process to have Excel provide those numbers for you. And then, of course, I have the numbers in decimal form right here. And then I've also told Excel, well, go ahead and display those as fractions of a 1/16 of an inch. It doesn't know that it should be reducing 11 and 12/16 to 11 3/4. You've got to know that yourself. But essentially, that works very, very easily. Okay, so what is the easiest method to do this then? If I've shown you an easy method, an easier method, and an even easier method. Okay, the easiest method is right down here. This math formula gives you the focus points of the ellipse. This says that with the major axis, 1/2 of that being 23 and 3/4 of inches, and the minor axis, 1/2 of that being 11 and 3/4 inches, you plug that into the formula here, and you get 20 and 5/16. Excuse me, 20 and 5/8. So what that means is that at 20 and 5/8 of an inch from the center point here, wherever the center's at, you would measure over 20 and 5/8, which is right out here. And you could put in a nail or a screw or something at that point, and then you would spin this around and do it exactly the same way, measuring out 20 and 5/8 in the other direction. Put in a screw or nail here and also over here. And then what you can do is you get a string and you run from the location over here where you've got your nail to the location that you've got over here. And you have to have enough slack in that string so that if you were to have a pencil or a pen up here at the top, that string has to be able to stretch tightly up to here when it's connected to the focus point that's over here and also the focus point that's over here. And when you do that and you stretch from up here around, it'll actually trace out exactly the shape of an ellipse. Because the definition of ellipse is that it's the same, whatever point you're at is always the same total distance from the two focus points. And so that would actually trace out an ellipse. And you would do that, of course, in one quadrant of this. And then you can cut that out on a bandsaw, whatever that happens to be. And then that would give you a template that you could then use with a flush trim bit or a pattern bit and the router to cut it into whatever board you're going to have the ellipse cut into. So that's an extremely simple method of creating an ellipse. Okay, and I promised you that there was a hard method to create an ellipse as well. The hard method has taken me about 3 days to put together in my spare time after work each day. So I would say that that's probably not the easiest way to create an ellipse, but it's possible to do it that way. Give me just a moment to get a couple things moved in the frame, and then I'll show you how to create an ellipse the hard way. Okay, the hard method involves creating a jig for creating ellipses or ovals. I know that Rockler makes a jig for creating ellipses. It's my understanding that some people have been unhappy with that jig, that it has various flaws. It's also quite limited in terms of the difference between the major and the minor axis in terms of the dimensions. This jig that I put together will cut an ellipse that's at least 6 feet long in the major axis, and I haven't checked to see what the difference can be in the minor axis, but I'm sure that it is quite large. Okay, so this is the bottom of the jig. I have double-sided tape applied to it. Here on this plywood, I've marked out the center location of where the ellipse needs to go, and the top of the jig looks like this. There's 14-degree dovetails in here, and here and here. This board measures 12 by 12, but because we have these slots going at angles from corner to corner, we actually have more of a difference between the major and the minor axis than just 12 inches. So these will move through the dovetails that are in here, and then it can be used to trace out the pattern of an ellipse. Okay, so what I'm going to do is I'll put this into the center of this board. I'll align the center points that I have here, and while I'm doing that, I'll show you a build video of how this jig was created. Cut a 14-degree bevel on both edges of the 1 by 12 inch boards, and also cut a 14-degree bevel on all 4 edges of the 9.5 by 17.5 inch board. After cutting the bevels, use a speed square or similar square with a 45-degree angle to draw lines coming from the corners on one edge. And then use a bandsaw to cut along those lines. You should be able to split those lines in half using the bandsaw blade. You may then do a partial assembly just to confirm that everything is fitting correctly together. Make sure that you have the small 1-inch wide boards so that the narrow face is up, and then align the other triangles so that they have their long face up. We will need to cut the long triangle in half, roughly where the ruler is at the table saw, and cut a 14-degree bevel on that cut line, both left and right, making certain that we have the bevel pointed in the correct direction so that the long side of the triangles will be up when this is reassembled later on. The only way that I could find to get the correct bevel direction on the table saw is to run the miter gauge backwards in the miter slot. You could likely do this using a radial arm saw just by tilting the blade in the opposite direction. or on a sliding compound miter saw or something similar. You may then cut one of the 1x12 boards in half and then rough out the layout of how the boards will be glued together for the ellipse jig. Use a pencil to number each of the triangles in sequence so that the triangles may be put back into the same location later. As you take off the triangles, also number the bottom board for the triangle number as shown below, as shown in the video. Use a framing square to connect the corners of the baseboard together with a straight line. Measure your tapered boards on the long side and verify that it's 1 inch across. If so, then take a ruler and measure 1/2 inch in each direction from those lines in the middle and make a mark, both near the center and near the edges. And then connect those lines using a pencil. That marks where the boards that are cut to go into the center will be placed during assembly of the jig. I will be using screws and glue to attach the triangles to the base piece because I'm using older Baltic birch plywood and I'm not certain that the glue on the surface layer is still in good shape. So I'll use screws to make sure that the triangles do not shift, in addition to using glue. You'll want to make sure that the triangles are flush against these boards that'll be sliding through the middle, but you want to make sure that there's still a thousandth or two of movement between each of the triangles and those boards that'll slide in between, so that these boards will be able to freely move back and forth. What I suggest that you do is you get one corner glued up at a time, maybe by using this longer board in the center and then using a shorter board over here, and then you would be able to bring in the other triangle. And then once you get these two triangles fixed into place, then you can move the short board up toward the top and then get those two triangles set in place. You do want to make sure that these short boards will flow through smoothly without too much binding, but you don't want them to be too loose. As you can see down here, you would want them to be closer than that when they're glued up. If you don't want to use screws, you can use a brad nailer to shoot nails in, but once again, because I'm not sure that the glue that was used on the surface veneers of these plywood pieces are in good shape, because the plywood is old, I'm going to use screws instead of brad nails along with the glue. this overhang may be trimmed back using a bandsaw, and then flush trimmed back to this board edge right here to make it look nice. I have the corners of the triangle cut back to just beyond where the edge of this bottom board is at. As you can see here, I've done that on all 4 edges. And now what I'll do is I'll use a flush trim bit with this sitting on the table on top of bunch cookies. Run the flush trim bit around all 4 sides. Now the unfortunate thing is that with the 2 bottom bearings on this flush trim bit, it would make contact with the table if I didn't use the bunch cookies. The stud on the bottom of the bearing would make contact with the table, and so that's why I've got to use the bunch cookies. And I'm trying out this plunge base on this Milwaukee router today just to see how well it works compared to the Bosch routers. Okay. I've got a route in this direction. It seemed to do decent cleaning it up. Now this was kind of an optional thing to do, but I went ahead and did it just so that the jig looks a little bit nicer. Okay, so we've got the jig here essentially completed. Now I've decided to make the boards 3 inches long, so they're 1 inch wide by 3 inches long. And of course they have a wide side and also a narrow side. On the wide side, you want to make a mark right in the center of the board. So it'll be 1.5 inches from this direction and 1/2 inch from this direction. After you get it marked, use a center punch to mark the center of it. And then of course, do that to the other board that you're going to be using in the center. And then this bolt, which is 1/4 inch in diameter and 2 inches long, that'll be going up through the bottom with the head countersunk into it. So you'll have to figure out what diameter of a drill bit you'll need to bury this head without it rubbing on any of the corners of the bolt head. And of course, you'll drill out the rest of it 1/4 inch for the shaft to fit into. And before you insert this bolt, you'll want to use some paste wax on the shaft and also on the head to lubricate that in the board. For the 1/4 inch bolts that I bought, a 1/2 inch diameter drill bit seems to work well to countersink the bolt head. You only need to go down as deep as necessary to bury the head. As you can see there, it just barely goes in. a very short distance. So now that I've got the countersink drilled out, I can drill the through hole for the 1/4 inch shaft. Okay, while you're putting paste wax onto the bolt, the portion of the head here and also the portion of the shaft that goes through, go ahead and apply some paste wax to the sides of these and also to the bottom of both of those boards, and also in these grooves in here. You want to make sure that you've got a good amount of paste wax in there as well. If you want to turn this into a circle jig, you can easily do that by using this spare piece of wood. What you would do is you would drill a hole through the center of it. You can measure this out, whatever it was, 12 inches long. I believe it was 12 inches long originally. Yep, this is 12 inches long. So you could drill a hole at 6 inches from one end and a 1/2 inch over, drill out for the head of another bolt, and then you could countersink that in, and then of course drill a through hole. And then what you would do is you would drill a hole here for a screw and another hole here for a screw, and then you would just simply screw it in place with it being centered in the jig, and that would turn this into a circle cutting jig if you don't already have one. Okay, so then these should go into here, one in each side, just like that. Now we're ready to build the rest of the jig that connects the router to this. I have this leftover piece of 3/4 inch plywood from a previous video where we cut a circle out of this. I have over here about 4 3/8 of an inch from the edge of the board to the edge of this where the circle was cut out. So what I could do for the arm of this jig, I could actually make the arm roughly, it looks like 4 inches wide, maybe 4 1/4 inches wide. And I could make the arm somewhat long. I could go, it's like almost out to 35 inches long in this piece of scrap plywood, out to here. That might work out. Maybe I'll make it so that the arm is 34 inches long and 4 inches wide to accommodate the sheet of plywood that I have available to me. And then what I'll do is I'll cut a slot down the middle that's a 1/4 inch wide for these 1/4 inch bolts. Now because this is not Baltic birch plywood, it's not going to have the same strength as Baltic birch plywood. And so what I'll probably do is when I'm cutting the groove that's going down the middle, I'll leave spots where I do not cut the groove so that it's still connected from this side to this side. And I'll probably do that a couple times down the length, and that should add some strength to this that I wouldn't otherwise have if I just had one continuous groove going from end to end. So I'll do that next. I'll cut this to width and to length, and then we'll come back and then we'll cut the groove that goes down the middle of this. I've laid out the location of the 1/4 inch slot that we'll be cutting in. It is set up so that it starts 3 inches from the one end. This is the end that the router will be connected to, and then it ends an inch from the other end. Every 10 inches or so, I've left a 1/4 inch area here that will not be cut. And so what that'll mean is that this will be less likely to split apart, to expand, or to otherwise twist as we're using the jig. And so roughly every 10 inches or so, I have a little piece of wood that's going to remain in here. I've set up my plunge router with an edge guide so that the 1/4 inch bit that I have mounted in here will be cut down. We'll cut the slot down the middle. I've used the 1/4 inch setup block with the bit touching the surface to set the first pass depth. And then once that's cut, I'll switch over to a 1/2 inch depth using a 1/2 inch setup block. And then I'll switch over to a 3/4 inch depth using a 3/4 inch setup block. For the last pass, I'll have to use some sort of a waste board underneath it. So I'll probably use this board as the waste board. I've got clamps here to hold it in place, which means that I'll have to move these clamps out of the way to get this last slot. But that won't be too much of a problem. Okay, let's go ahead and we'll cut. As a reminder, we need to have the router move from left to right. In other words, toward the camera with the edge guide over here on this side, so that the router bit's cutting motion will try to pull this edge guide into the board instead of push it away from the board. Okay, I'll sink it all the way down, and then I'll use this 1/4 inch setup block again to set the offset, which should bring me down a total of 1/2 inch. Okay, now we're ready to go down 3/4 of an inch. So I'll take this all the way down. And then I'll use the 1/4 inch setup block again to allow it to go down another 1/4 inch. Which should get me all the way through the plywood now. Okay, so the slot's been cut all the way through. Now we just have to find a way to attach it to the router. Hey, before we try to connect this to a router, first what we need to do is on the bottom side, this is the top side here, on the bottom side we need to make it so that a nut for a 1/4 inch bolt will be recessed into this area here so that we can fully clamp the bolt here against the top and the bottom of this board here so that it cannot move in relative position. We can't just leave it unprotected here, or to leave this without any kind of a clamping mechanism. And what that means is that this little section here that's not threaded on this bolt is going to present a little bit of a problem to us because the nut's got to fit onto there, and so you might want to use a screw instead of using a bolt as I did here. So I've got to get the router set up again with a 1/4 inch bit and the edge guide. I need to offset this area here, go down maybe a 1/4 inch or so, maybe not quite a 1/4 inch, but somewhere around there. The nut is 7/16 wide, so I need to go 3/32 of an inch in on each side of what's already been cut here. I did not draw this extremely accurately. It's off ever so slightly. So I'll have to make sure that when I set up the edge guide, I have it so that it's set up accurately so that I'm taking off 3/32 on each side so that a 7/16 inch wide nut will fit down in there nicely. Okay, so I'll take care of that next, and then I'll bring the camera back. Okay, the nut is 3/16 of an inch tall, so what I'll do is I'll actually make this a 1/4 inch deep, and I did that using a setup block. And so now I'm ready to cut this edge that's on this side. Once I get that cut, then I'll set up to cut the other side. I don't know if I can just rotate this board around without having to reset the jig, but we'll check it out and see how well I had this original slot centered in the board to see whether or not that's possible or if I need to adjust the jig. Now the board is sliding over and it's rubbing up against the edge of this bench, and it's throwing off the edge guide. Okay, the first half of it is cut. That should be over 330 seconds. And that looks like that'll probably work. Yeah, it's going to be tight. Okay, so let's see what happens if I flip this around. If that puts me into the right spot. And no, it does not. We'll have to readjust. I'm over maybe... Oh, maybe that is right. That's over just a hair too much. Maybe a 32nd of an inch. Okay, let's see if we can use the micro adjust. That might be right there. Let's try it. Could be a hair too much. Let's give that a shot. see if the nut fits. It looks like it's going to be a tight fit, if it does fit. Okay, so that looks like the nut will fit through there. Let's make sure that we can get the bolt up through the center. That's going to be a tight fit, which is what we want. Okay. Yeah, it looks like that'll work. The nut is in there securely, and the bolt is coming up through the center, just like we want. Obviously, this is upside down. We'll have to flip it around, but that should only take a couple minutes to do that. Okay, our ellipse jig will be mounted to the base plate that we created for the plunge router in a previous video. And oddly enough, with these 2-inch long bolts in here, this board is level running across this way with the top surface of the sub base that we created. Specifically these 1.5 by 1.5 inch boards that are here. So then what that means is that I can simply use 2 or 3 screws right in here to lock this board, the arm of the jig, into the sub base that we created. And so that's a rather simple process. Now, if you create this jig and it doesn't work out that perfectly for you, you can always add a shim down here at whatever thickness is necessary to reach the sub base that you build for your router. So I'm going to get this attached. Okay, I've decided to mount this arm to the other side of the sub base so that I can actually work from this other end out here. I have found the center of this board, and then I came back 2 inches from that, use the square to make sure that this is on straight, and now I've got 3 screws that are pretty beefy that are 2 inches long, and I'm going to send those into the sub base. I've already got one in, I'll put another 2. Okay, let's make sure that we're still squared up. Okay. Okay, so now that is connected. Let's get some of these things out of the way. Okay, so this should take the router around in an elliptical motion, because we've got 2 different spacings here, and it may be a little bit hard to see right now, but it is coming in closer when it gets over here than when it's over here. So this is the time-consuming way to actually create an ellipse, but since this is the method that other people show in YouTube videos, I thought it was my duty to show you the more difficult method, whereas the method using mathematics is much faster. Okay, so we'll play around with this again later on. I have the jig assembled now with the base of the jig mounted in the center of the board that will have the ellipse cut into it. I have this arm set up with the pieces going into essentially the farthest point to this direction that I can for this one, and this one in the center, and I have the arm not quite shifted far enough out this way to reach the full extent of the major axis, but that's okay. The issue that I've got is that with this jig, even as large as it is, the throw in the minor axis is not enough of a difference from the major axis to allow the router to come in close enough. Right now, the router bit would be about maybe 4 inches away from the edge of where it needs to cut. At this location, while if I swing it over this way, it's about a 1/2 inch away in this direction of where it needs to be right now. I could shift this arm this way a 1/2 inch, which would help. The difficulty there is that if I do that, then when I swing the arm around, that means that the router will be an extra 1/2 inch away from where it needs to cut in this direction. Okay, so that's the first problem that I have. The second problem that I have is that this router base that I created a couple videos ago is just a little bit too large to be used with this jig. If this router were able to get close enough to where it needs to cut. So I think what we're going to have to do is say that this style of a jig simply cannot be used to cut an ellipse that is 4 feet on the major axis and 2 feet on the minor axis. So it looks like we'll have to go back to either the simple method, the super simple method, or something similar to that to actually cut this ellipse. So that's a bit of a disappointment after spending a couple days building the jig. But it does actually trace out the shape of an ellipse, which is what was desired. However, the ellipse cannot get to be the size that's needed for this particular board, as you can see here. It does, in fact, trace in what appears to be an ellipse. The other problem that I have is that the double-sided tape that I put underneath this base is simply not sufficient for holding the base in place to the board that's going to be cut. And what that means is that if you were to use the style of a jig, you would have to mount the base to the bottom side of this board and then sink a screw in through here and through here to hold this base in place, because of the amount of torque that's exerted on this thing when the router moves around in a circle is simply too great for that base to be held in place with just the double stick tape. (20 5/16). (20 5/16). 20 Here's the corner of the ellipse that will be used for the pattern to cut out the full ellipse using a template bit. What I'll do is I'll extend this up an extra inch here, and then extend this an extra inch here, and that'll be a straight extension, and that way the router has a starting point and an ending point that will not cut into a part of the ellipse that should not be cut. So this is the most easy way to create an ellipse on an object, such as a table or something else. If you cut it into an MDF template, you only need to use 1/4 of this for your template, and then you can double side tape this template once it's been cut at the bandsaw or a jigsaw and then smoothed out using some sort of a sander like an oscillating spindle sander. Then you can use this as a template for cutting out all 4 quadrants of this ellipse, while the jig method was not able to actually cut the ellipse. That's all for today. Thanks for watching. Bye!